Here's a problem where we just need to apply the integrated rate law for the kind of reaction they indicate twice. It's really two problems in one. So first of all, take a close look at the top. They tell us that the rate equals K times pH3 all raised to the first power. The sum of the exponents in that expression is 1. That tells us that this is a first order reaction. That's really important. From there, we just need to apply the integrated rate law twice. In this case, the substance, the lone reactant, is phosphine, pH3. And I'm just applying the first order integrated rate law. So first part, it says it takes 100 seconds for 1 molar phosphine to decrease to 0.25. Let's plug in those numbers. At the time they observed, the concentration was 0.25. That was after 120 seconds. Oops, 1 second here. That's negative K times 120 plus the initial concentration, natural log of the initial concentration, which was 1. Here we have an equation that we can work with. Pull out the calculator, start to simplify. The natural log of 1, of course, is 0. So if I divide both sides by negative 120, we get a value of K of 0.01155. We'll round at the very end. So we've got our value for the rate constant. Since it's a constant, it's not going to change. But now we consider the second part of the question. This time they want us to find how much time is needed for 4 molar phosphine to decrease to a concentration after a certain time to 0.32 molar. The same equation can be used. It's just that we're going to solve for a different variable within the equation. Now we know K, but they're going to ask us to solve for time. The concentration at the time that they were observing was 0.32. Our value of K we're going to pull from our previous work, 0.01155. This time we're solving for time, so they'll leave that as a variable. And the initial concentration in this case was 4. So we have one equation and one variable, and we can solve it. Pull out the calculator and start to simplify. And we'll divide to get the time of 219, and since we've been working in seconds all along, the units are seconds.